Welcome to the 13th lecture on computational mathematics with Sage Math. In this lecture, we will continue exploring classes in Python. In the last lecture, we introduced classes and also methods inside classes, including some of the special methods like init and call. So, let us continue with the last lecture. Now, let us look at some other special methods. So, there are several special methods. So, we have already made use of init, we also saw del, and just now we saw call. str and repr, these are the special methods which is used when you call print statement. So, print we saw in case of complex number z, we say when we say print z, it printed that value. Okay. Similarly, the repr also has similar behavior, but there is a small difference between str and repr methods. Okay. So, next let us look at, there are these special methods for adding. For example, if you say a plus b, it should add the two objects a and b. We saw that z and w in case of complex gates. So, what it does, when you issue this command or syntax, it invokes a method called class method called add, and it will say a dot add and b. Similarly, sub is for subtraction, mul for multiplication, div for division, pow for power, lt for checking less than, and gt for greater than, le for less than equal to, ge for greater than equal to, eq is for equation equality actually, and ne for not equal to. Okay. So, these are default methods, and there are some more, there are many more actually. And if you look, so there is one called boolean, bool, this is boolean expression whether something is in some object, right, and length is also there, len, and then you have absolute value abs. So, these are some default methods, there are many more, but these are very commonly used special methods. Let us create, for example, some class or type which makes use of these type of methods. Okay. Before that, let us just briefly look at what is this str and rper. So, for example, if I create a class called triangle with initial values as a, b, c, that is the side length, right, and then suppose we want to print the area of this triangle. So, using Heron's formula, so we can create a method def area semicolon from math import sqrt, find out this semi perimeter which is a plus b plus c by 2, but here a, b, c are self dot a, self dot b, self dot c, and then create the area which is square root of s into s minus a into s minus b into s minus c, and return s. So, you can see here this method is exactly the same as you create any function outside the class. This we have seen it earlier, right. So, when it comes to creating a method, there is no difference between creating method and creating function. So, actually the class methods are nothing but functions, right, user defined functions. So, let us run this, okay, and let us call this triangle. So, triangle S, I am calling this as T, and the triangle spelling wrong, okay, triangle, it does not matter, whatever name you want you can give, but let us, okay. So, this is triangle, and then I am calling this right. Now when I see, if I simply ask it to print t, it will give me, it will not print what I wanted actually, but what it has printed, it has printed the address, the location in which this t is stored in the memory. Okay. So that is what it is. So if I want to print this as something, let us say it is a triangle with sides this is not a good, this is not enough. Okay. Similarly, let us look at, so once we have passed this, created this triangle, then we can get its area, t dot area, and the area is 6.0, right. Okay. So we cannot use print on t because it does not understand, and that is where str comes into picture. So you can create a, you can redefine this triangle class and add state a method called str, Now for the time being, let me just have str, and what is that it returns? So str should always return actually a string. So we are saying that it is a triangle with sides. So this will get replaced by ABC, percentage d, percentage g, percentage g. These are the replacement operator for ABC, right. So now if you return the spelling mistake, return. Okay. Now if you create a triangle T with sides 3, 4, 5 and then ask it to print, that's the spelling again, this triangle, then if you ask it to print, it will print the triangle with sides this is what we wanted to return. So this is, if you want to print something, some object which you have created, then you must have inside this str. Okay. You could have also used REPR, right. So I have just added in this. So whenever actually when you call print, and in case it is not, first it will look for str, if it is not there, it will look for REPR method, and then it will give, but RPR can also be used for evaluating the value. So it can return actually anything, whereas str will return only the string variable. Okay, that's the difference, but the role of these two are quite similar. Okay. Of course, these are also used by the developers. So developer will know more about this classes whenever they see representation method. Okay. So let us make use of these concepts and these special methods in order to create a class or a type for 3-dimensional vectors, right. So vectors in the space having 3 coordinates. So how do we create this? So let us look at this. So we are giving the name vec3d, and since the calculation of vector calculation will require maybe square root and things like that, especially if we want to find the length of a vector, we will import this math module, and so this is the class name. Now first you initialize this vector 3d with the each coordinate x, y, z. So self dot x equal to x, self dot y equal to y, self dot z equal to z, and then we want to add 2 vectors. So how do I create? We will make use of the special method called add, and then the argument is self followed by the other second, right. So once you have created a vector, let us say v, and you want to add to w, then we have to say v dot v plus w, and w is the other will be replaced by w. Okay. So what should it return? It should return vector vec3d, that is the class, the type, and self dot x plus other dot x, self dot y dot plus other dot y, self dot z plus other dot z, right. So, x coordinate is added, x coordinate of x is added to x coordinate of others and so on, y coordinate of this vector is added to y coordinate of the other and so on. Similarly, subtraction, so instead of plus you have to say minus here. Multiplication, so multiplication here we are replacing it by the dot product actually. So, multiply the first coordinates, second coordinate and third coordinate and add all of them, that is the multiplication. Similarly, if you want to check whether the two vectors are equal or not, we will use EQ, and then in this case double equal to x coordinate is equal to x coordinate of other, x coordinate of self is equal to other coordinate, y coordinate of y coordinate of self should be equal to y coordinate of other and so on. Okay. Similarly, absolute value is for the length, so that is by math SQRT of self dot x square plus self dot y square plus self dot z square. Then you can also check whether two vectors are equal or not. So, NE not equal to, so self dot equal to and other. So, this here this is just going to return true or false. So, in case it is true it will return true, otherwise false. So, that is why it is self dot EQ double underscore EQ and others. So, it will check whether the self, that is one vector, let us say V, is equal to other, that is W. Similarly, dot product. So, dot product is very similar to mult, right, but this is our own user defined function dot. And similarly, another method is cross product. So, for cross product what we are doing, we are defining x, y, z variables which is self dot. So, each coordinate we are defining. So, I am sure all of you know how to define cross product of two vectors in the space. So, we are just writing each coordinate and then it is returning as a vector x, y, z. Okay. And also distance between two vectors. So, self and others. So, this is z is equal to self minus other and then return the absolute value of that, right. The distance between two vectors is nothing but absolute value of or the length of the difference between the two vectors. Okay. And then you want to print the vector. Whenever you are defining the vector, you also want to print. So, we are invoking this method str and it returns three coordinates x, y, z. Okay. So, let us run this and let us create a vector. Let us create two vectors u and v. So, u is 3 1 minus 2, v is vector 3d minus 2 2 3, and if I ask it to print u and v, it will, when I ask it to print u and v, it will invoke this last method which is str and it is printing this x coordinate, y coordinate, z coordinate as a tuple. If you want, you can add something inside this. This is a vector in 3 dimension with coordinates this, all these things can be added. Okay. Next, you can check whether u is equal to v. In this case answer is false. You can add two vectors u plus v, small v, then it will but it is not printing. So, I will have to say print u plus v, print u plus v. Similarly, you can say u star v, then it is giving you the dot product. Similarly, I can say u dot v, that is again dot product, right. So, the moment if you say u star v, it will invoke this mult method and so on, right. So, similarly, you can do other operations. So, for example, I can say find the cross product. So, if I say u dot cross v, and since it is a vector, I have to ask it to print. So, I will say print, or let me say this is equal to w and then say print W, it will print what is the cross product. You can check, since I am sure you know that when you create the cross product or U and V, let us say that is W, then W is perpendicular to U and V. So if I ask for what is U dot W, this should be 0. Similarly V dot W should also be 0. Okay, so both are 0, right? Okay, next let us create another class called quadratic, right, to solve a quadratic equation. And in this case we also will print what is the discriminant and what are the roots. So these are the we are creating one initialization and then call function to print the what is the value of the quadratic, what is the quadratic, how it looks like, ax square plus bx plus c, that is the call function. And it gives you the discriminant method, which will give you the discriminant, and then roots, again it is exactly same as what we have done earlier. So in case of it real roots and complex root, it is just giving, in case of complex root it is printing that the roots are complex and printing the value, and we are making use of sqrt from numpy library. So therefore it will give you both real and complex root. Okay, so here is actually this, in case of square root we are using square root from scipy library in case of complex root, because scipy sqrt has both real and imaginary part. Okay, and then at the end you print. So we have, though we have we can call the what is the value of the function, we can also create a printing string for printing, right. So this will print actually fx, you can see here fx is equal to ax square plus bx plus c, and it will replace value of abc by that value. That is what it is done. So it is saying that print fx equal to, so that is the initialization. In case a is present, it will add a into x square, and in case b is present, then it will check whether b is positive or negative, right. If it is positive, then it will put plus in between. If it is negative, it will put minus in between. Similarly for c, so if c is present, then we will check whether c is positive or c is negative. If c is positive, after bx it will put plus, if it is negative, after bx it will put minus, and ultimately it will return s, right. So let us run this and let us call this. So q is equal to quadratic 2 3 minus 5, and if I say print q, that is what you can see here, it is printing 2x square plus 3x minus 5. That was the role of this str. And we can ask for what is discriminant of this, we can ask for what are the roots. So all these things are available. So see, you can see here the advantage of creating class is that you can have different methods which will actually do tasks at a time. So if you have a big task, you can split this into small tasks. That is what exactly I meant by saying classes are blueprint. Okay. And so when you create, let us say if you want to construct your house, first you create a blueprint, and inside that you keep on adding. The bedroom will have these features, bathroom will have these features, kitchen will have these features, and so on. So that's exactly is the role of classes, right. We have created the several attributes or variables, and which we accessed once we have created the objects, but there are variables which are those variables which we have created, these are called public variables, but there are variables which are also private variables and protected variables. Okay. So this public variables can be accessed from anywhere, Okay. So, public variables are those variables that are defined in the class and can be accessed from anywhere in the program using dot. That is what we have, dot operator, that is what we have seen. And here anywhere means that it can be accessed from within the class as well as from the outside the class. That is what exactly we saw, right. Whereas private variable are those variables that are defined in the class with double underscore. You have to prefix it by double underscore, and these variables can be accessed only from within the class and not from outside. Okay. Similarly, if you want, there is another variable called protected variables that is defined by giving single prefix that by single underscore, and actually this effectively prevents it to be accessed unless it is from within the subclass. Okay. So, it again it is cannot be accessed. However, these variables can also be accessed if one wants. So, in some sense it is not that you cannot access at all. Only thing is that a good programmer will not try to change these variables, protected variables and private variables, whenever they see this kind of variables. Okay, because they would know that this is a private and protected variables. So, that is the difference. Okay. Now, let us see how we can create these variables. So, let us create again this student class, initialization as name, age, average and hobby. So, first name is actually a public variable, this we created as it is, which we have seen earlier, whereas let us create a private variable called age. So, how do we create? Self dot 2 underscores and age equal to age, and similarly another private variable as average, and let us create a hobby as a protected variable and with this single underscore, right. And then let us ask it to display. When you ask it to display, it should display this all these variables, public variable, private variable and also protected variable. So, within this class, this method it can all print all these things. Okay. So, of course, it can print public variable and it can also print the protected variable as well as private variable, but outside this class let us see whether it can do. So, let us run this, and now let us create a student Mr. XYG, and its age is 23, average is 54.24 and his hobby is reading. Okay. So, when we create this, and then let us see, when we want to display it, when we call this method display, it will print all these things. So, all these variables, whether public or private, all these things are able to we are able to access. Okay, right. Whereas, if I say a dot name, name is a public variable, so it will be able to print. But if I say a dot double underscore age, which was a private variable, it will not be available. It says that the student object has no attribute this, and that is how we created dot double underscore. Of course, if I say dot age, it of course it is not available, but even with dot double underscore you cannot access it. Okay. But how do we access? As I said, it can still be accessed. So, in order to access, you have to say a dot underscore the class name, which was students, and then double underscore age. Now, you can access this. So, this is 23. Not only you can access, you can even change. So, for example, instead of age 23, if I change it to 32, and next time when I ask it to print, the age, it will show 32. So, as I said, though it is a private variable, but still it can be accessed with some efforts, and it can also be changed. Similarly, you can look at the hobby. So, hobby was private variable, it is a protected variable. You can change the value of this. So, again, though it is protected variable, still it can be changed, but as I said, in whenever a good programmer looks at these type of variable, they will refrain from changing, because they will think that this is a protected variable. Okay. Similarly, if I say a dot underscore average, it will not be available, whereas if you want to get access to this, you have to say a dot underscore student double underscore average. Okay. So, this is the meaning of protected variable, private variables and public variables. Okay. So, that is what I say, a responsible programmer would refrain from accessing and modifying instance variables prefixed with underscore and double underscore. They will know that these are private variables and protected variables. So, they will not make any changes, right. At the end, let me also tell you, you can also create what is called private methods like private variables. And how do we do that? So, the way to do is, in the name of the method you prefix double underscore, this is double underscore, and then you define exactly the similar to what we have defined earlier. Okay. Now, in order to define an object, let us again create an object, a student A with name Mr. XYZ with age 24. The average value is this, and when we ask what is the name, it will be of course give you. If I say a dot display, this says that it does not have attribute, because we have created as a private method. So, if I want to access that, I have to say a dot underscore student double underscore display, exactly similar to how you accessed private variable. Okay. So, again this is what you have. So, these are the private methods. Of course, there are many more things when it comes to dealing with classes in Python. This is very important concept as far as object oriented programming language is concerned, but we are not going to get into all the details, because our focus is to learn mathematics using SageMath. And since SageMath is object oriented SageMath is based on Python, which is object oriented programming language, I thought it is a good idea to introduce briefly classes, so that you will be able to understand it much better. At the end, let me leave you with some simple exercises. So, there are 4 exercises of creating classes. The first exercise is create a Python class with name sphere. Sphere is the name of the class, and it should have input radius. So, you create the object with some radius and then print its volume and surface area. So, these are the 2 methods, volume and surface area. Similarly, create a class called account for account details of some customers in a bank, right, and which has initialization as the account number and starting balance, and inside that you create 2, let us say, method called deposit of an amount and withdrawal of an amount. So, when you deposit an amount, the initial it should add to initial amount. When you withdraw, of course, withdrawal should be possible only when there are enough balance available, and then when you withdraw, the balance should get deducted, and of course, for printing you can use str method. Okay. Create another class called rational for doing computation with rational numbers, and use special methods like add, subtract, multiply, as we have done for vector 3D, so that you should be able to add, multiply, divide, subtract rational numbers, even equate. Okay. And the last one is to create a class called country, and that stored name of the country and its population and the surface area, the land area, and then write program to read in a set of countries, which reads a set of countries and prints the country name with largest area and the country name with largest population, and also the country name with largest population density. So, these are the 4 simple exercises. Of course, we will be posting the solution of these exercises, but you should try to do it. Okay. So, in the next class onwards, we will be actually focusing on, we will start learning SageMath and explore mathematics with SageMath, but going forward you should also look at some more packages in Python. For example, you can look at a package called Pandas, which is very important for data analysis. It deals with handling data and doing various kinds of data cleaning and things like that, including the plottings and things like that. So if you if you want to learn more detailed on Python as a mathematics student, these are the things which you should concentrate on. Learn basic Pythons, looping, then learn how to create your own functions, make use of NumPy library, SciPy library, SymPy library, look at these classes, and if you want to deal with data analysis, maybe look at the Pandas. Okay. So I hope this 2 weeks of introductory lecture on Python will actually make you well equipped in order to make use of Sage Math in a much better way. Thank you very much.